differentiate. In part A, we got the function equals 2 raised to x. This is an exponential function, and as we've seen, when we have a number raised to x and we want to find its derivative with respect to x or prime, that is always the same thing times natural log of this base b. Okay, if this base b happens to be e, then we have ex, then its derivative would be e to the x ln of e, and ln of e is 1. Okay, so this is ex times 1, so we get our familiar exponential function. So using this, it will be just one line. Then using this formula, derivative of 2 raised to x is itself times ln of 2. Done. But if this function is not only x, not only t, more than that, then we call that as chain rule. So if we have something other than simply x, let's say u, then from the chain rule we need to multiply by derivative of u. Okay, so we'll be using this for part B. So let's use that. So f prime t is itself, this is an exponential function, so itself times ln of base 5 times, since this is sine t, not only t, we need to find its derivative. Derivative of sine t is cosine t. Here derivative of x would have been 1, and we didn't write times 1. So here derivative of sine is cosine t. So basically using this formula. Okay, now for part C, we use the same formula like this, because we have not only theta, we have a function of theta, and we call that as u. So we'll be using this formula. So let me copy down here. So this one, then derivative is exponential function, so itself, it's not sine, it's tangent, times natural log of base 3 times derivative of this. Last time derivative of sine was easy, just one step, so derivative of sine cosine, but here we got a product, so I'm just setting up this derivative. Here now we need to use the product rule, okay, because we got theta times tangent theta. So what is the product rule? U times v, derivative is u prime v plus v prime u, and our u is theta, v is tangent theta. So this part is done. ln3 is a number, decimal number, so I'm going to write in the front. No parentheses needed, times 3 raised to theta tangent theta times u v derivative. So derivative of theta with respect to theta is 1 times tangent theta. Okay, 1 times tangent theta is just tangent theta, plus derivative of tangent theta is secant square theta times u, which is theta, times theta, but I want to write that theta in the front. Okay, times theta, that's not in part of secant, that's times theta, and here, and this is it, final.